Lesson: Core Concepts and Terminology in AI. Artificial intelligence is a multifaceted field that encompasses numerous core concepts and terminologies. Professionals seeking to enhance their AI proficiency must grasp these foundational elements, which serve as the building blocks for more advanced applications. Understanding these concepts not only facilitates comprehension of AI processes, but also empowers individuals to apply AI technologies effectively in real-world scenarios. At the heart of AI is the notion of algorithms, which are sets of rules or instructions given to a computer to help it learn on its own. Machine learning, a subset of AI, involves the use of data and algorithms to imitate the way humans learn, gradually improving its accuracy. Within ML, there are various types of learning, including supervised, unsupervised, and reinforcement learning. Supervised learning occurs when an algorithm is trained on labeled data, meaning the input comes with the correct output. Unsupervised learning, on the other hand, deals with unlabeled data, and the system tries to learn the patterns and the structure from the input data on its own. Reinforcement learning is a feedback-based ML technique where an agent learns to behave in an environment by performing certain actions and observing the results of those actions. Neural networks, particularly deep neural networks, are pivotal in driving breakthroughs in AI. These networks mimic the way human brains operate, consisting of layers of interconnected nodes or neurons. Each connection, or synapse, transmits a signal from one node to another, and the network adjusts these connections based on the data it processes. Convolutional neural networks are a specific type of neural network, particularly effective in image recognition and classification tasks. For example, CNNs have been employed successfully in medical imaging to identify tumors with a degree of accuracy that rivals human experts. The concept of natural language processing is also integral to AI. NLP involves the interaction between computers and humans through natural language. The goal is to read, decipher, understand, and make sense of human languages in a valuable way. AI-powered chatbots, for instance, utilize NLP to interpret and respond to user queries, enhancing customer service efficiency and effectiveness. Companies like IBM have developed sophisticated NLP systems, such as Watson, which can understand and process vast amounts of unstructured data to provide insights and recommendations. AI ethics and bias are significant considerations in the development and deployment of AI systems. Bias in AI can arise from the data used to train models, which may reflect existing prejudices or inequalities. For instance, if a facial recognition system is trained primarily on data from one demographic group, its accuracy may suffer when applied to individuals from other groups. Addressing AI bias requires careful dataset selection and preprocessing, as well as ongoing monitoring and evaluation of AI systems to ensure fairness and equity. Frameworks and libraries are essential tools for implementing AI applications. TensorFlow and PyTorch are two of the most popular open-source libraries used in AI development. TensorFlow, developed by Google, provides a comprehensive ecosystem for machine learning and other AI applications, offering abstractions for defining models and tools for training and deploying them. PyTorch, known for its ease of use and flexibility, is favored by researchers and developers who require dynamic computational graphs. Both frameworks support a variety of model architectures and facilitate the implementation of complex AI solutions. AI's practical applications are vast and varied, ranging from predictive analytics and autonomous systems to personalized recommendations and fraud detection. In the retail sector, AI can analyze consumer behavior patterns to personalize marketing strategies, thereby increasing engagement and sales. In finance, AI algorithms analyze transaction data to detect fraudulent activities, offering a layer of security and enhancing trust in financial systems. To address real-world challenges, professionals can follow a structured approach to AI implementation. The first step is problem identification, where the specific issue or opportunity is clearly defined. Next, data collection involves gathering relevant and quality data that will be used for training the AI model. Data preprocessing follows, where the data is cleaned and organized to ensure it is suitable for analysis. Model selection and training involve choosing the appropriate algorithm and framework, such as TensorFlow or PyTorch, and using the prepared data to train the model. Evaluation and optimization come next, where the model's performance is assessed and fine-tuned for better accuracy and efficiency. Finally, deployment and monitoring involve integrating the AI solution into the desired environment and continuously monitoring its performance to ensure it meets the intended objectives. AI's impact on industries is profound, with Gartner predicting that AI will create $3.9 trillion in business value by 2022. This underscores the importance for professionals to not only understand AI's core concepts and terminologies, but to also be adept in applying these tools and frameworks effectively. By leveraging AI technologies, businesses can achieve greater efficiencies, uncover new insights, and drive innovation. In conclusion, a comprehensive understanding of AI's core concepts and terminologies is crucial for professionals seeking to harness the power of AI. From algorithms and machine learning to neural networks and NLP, these foundational elements provide the basis for developing and deploying AI solutions. By utilizing frameworks such as TensorFlow and PyTorch, professionals can implement AI applications that address real-world challenges and drive business value. As AI continues to evolve and transform industries, staying informed and proficient in these core concepts will be essential for success.